Okay, so we will proceed on orthogonal components. So good thing is that we are in last phase now, and we talked about orthogonal component in a sense that orthogonal component, the concept of independent variable. This is what we have been talking about. The concept of independence in the variable independence, or whatever a class has attributes, and if they are attributes, they are independent to each other. Attributes, they are orthogonal to each other. So attributes which are independent to each other, and attribute which are orthogonal to each other, then it takes minimum space, in the sense the number of attributes required to address the same information is very less. So this is what we have been seeing, and the information that is kind of produced by the class, if it has attributes, those are orthogonal components, those are independent variables, then it is kind of the number of attribute is less, but information is same. Rather than, like, if I have, suppose that the example I keep giving, that if I have 20 million colors, then to identify each color uniquely, then think that how many bits of the space that we would need. 20, or suppose that I have a uh, uh, 1 billion color. Okay, now to have the 1 billion different color, then just think that how many MB or GB per object it would require, because each object's color would be different to other color, and there are billions of colors. Rather than that much, we probably need only 24 bit, only 24 bit RGB 888. That's it. Now, in terms of RGB, we can show the external research. Then electronics is, that is mathematical research. So I have personally seen many places. Like I had used to have a very slow computer like Raspberry Pi Zero and those kind of things, and I followed the algorithm what is expected. Okay, and it used to finish in 10 minutes. Algorithm, if I start, then for a minimum 10 minutes, depends upon the input, sometimes half an hour to finish one execution. Okay, but if I put it in laptop rather than Raspberry Pi Zero and then pushing it to laptop, in laptop it used to take 2 3 minutes, 2 3 minutes and half an hour. Okay, then I used to transfer the work when to laptop to execute. Okay, that is was the situation. Then I sat back and I thought of different algorithms. Okay, mathematics. It came to mathematics. Now in Raspberry Pi, it would take 1 minute. I never tried on laptop. Okay, 1 minute, 30 minutes to 1 minute. So that is mathematics. Rather than going for very fast computer, okay, rather than spending too much in hardware, rather than spending too much in internet and here and there, and then in labor work, it is worth to think in mathematical aid. I am not saying algorithm. Okay, what we talked about algorithm, but more in it, that is pure mathematics. Algorithm depends upon mathematics. So mathematics is the main thing. So if we no need to spend money, you think, think, keep thinking. Okay, so like the person who is a good mathematician, he uses his uh, peripherals minimum, like the mouth are peripherals to the organ, to the brain, eye, ear, skin. So these are peripheral to the brain. If someone touches, then it goes to brain, or we eat, breathe, see, hear, it goes to the brain. So the in mathematics you have to use it your peripheral minimum. Means spend minimum time in seeing, hearing, and eating, breathing, smelling. Use maximum time to think. So that is the main concept of mathematics. So in mathematics, you have to keep thinking. That is required. So whatever you get in mathematics, that would not only save your hardware, okay, it would save lot and lot of time also. Just think that someone would thought about independent variable and orthogonal component only with three color, red, green, blue. Now he can get all possible colors. So one class has only 24 bit, and now you can have as many colors as possible what you want. So that is the greatness of orthogonal component. Now we brought the orthogonal component in dot product and cross product in vector. In calculus, we brought the orthogonal component. Okay, so when we were kind of calculating, so in calculus we also saw, so directional derivative along a vector. So directional derivative along a vector. There we saw that we don't need tangential surface, linear, local linearity. We don't need chain rule also. Oh, okay, orthogonal components work very nice. Now, then we started discussion in the designing area. So in designing area also, we saw that orthogonal component makes sense if we have a single responsibility. If I have a class and a class has more responsibility, class has more reason to change, then those reasons are orthogonal to each other. How they are orthogonal to each other? In a sense that in the client side and in the service component, client component, service component. Client component depend upon user service component. So service component class is now it is distributed, rewritten in many orthogonal classes or the classes whose variances they vary in different directions. This is what the dimension reduction ability in machine learning, and there we find the different variance direction through Einstein. So now the client component depends upon the server component, and server component it is something like it has now the different orthogonal classes, and when we make change in one orthogonal classes, it should not propagate in other orthogonal classes. So that is the concept of uh, orthogonality as far as service component is concerned. And now that is the concept we see as far as client component is concerned, that you when you use a particular service orthogonal class, then it is not required that you need other class. When you don't need, means no need to instantiate other class, means if we are not dependent upon any particular method, then you should not see it. So that is the concept that we saw. Now the concept comes that kind of interface segregation, single responsibility in design principle, that where we can kind of think about the orthogonal components, and next is interface segregation. If we want interface segregation in the sense that instead of distributing the class in classes, rather than we will distribute the class in interface. I have a service class called printer. So printer service class would now be distributed among interfaces, not in the class. So if there is a guy called client component, okay. So if there is a guy called client component depends upon service component. Instead of depending upon service component class, client component depend upon, or it uses, it calls the service component interface. If there are four interfaces, there are four interfaces. Client component now uses interfaces, not the concrete class. Concrete class, it realizes the interface. So the client component depends upon interfaces. Service component derive or realizes the interface. So dependency is through interface. So this comes in a kind of called interface segregation. Please, if you have many roles that you see in a class, or orthogonal components or many reason to change, whatever, then please distribute it in interfaces, not in the class. If you distribute in the interfaces, then client component would not be dependent directly on the concrete class. It will be dependent upon the interfaces. What is interface sign? Okay, like I am pulling brake in a vehicle, in a car or in a motorbike or in a bicycle. So I am pulling the brake. Now brake is connected to the engine. So engine stops. Okay. Okay. Or or I am kind of pulling the accelerator. Okay. If it is like that, then it goes and controls the engine. Now accelerator is connected to the engine. Okay. If accelerator is directly connected to the engine, then if there is some problem that happens with the accelerator, okay, or suppose that problem happens, more we'll talk now. So problem happens with the engine. Okay, now I have to replace engine and accelerator because they are tightly connected to each other. This is how the client component and service component, if they are tightly connected to each other, then you cannot replace the service component at runtime. Now, if I replace engine, I have to replace the accelerator because they are tightly connected. All the screws and all the nut bolts are made for the particular engine. Now, if the accelerator is dependent upon interface, okay, so engine is connected to few uh, nut bolt that is predefined, and accelerator is connected to the nut bolt or that area that is predefined. The specification of the connection between engine and the accelerator, that region, the where they are connected, that is a specification is follow some kind of predefined specification. So there is a specification now. If engine changes, okay, if I need to change the engine, then I have to bring another engine which follows that specification. If that is the case, then I can just replace the engine, and the way they are connected through a specification, and it would work. The way like I have USB drive. Okay, so if my mobile is can be connected to any other peripheral through USB, then any peripheral who follows the USB specification can be connected to the mobile. Because the main thing is a USB connection port. That is the specification. Now, if I same battery charger or same anything else, same wireless mic, same mic, now can be connected to any of the mobile which support a USB connection. So like that, this is the interface program. Now, if a client component knows the interface specification, and the service component which realizes the interface, it knows that interface specification, then I can change the service component at runtime because it follows the interface. Okay, like that in the software also, don't be dependent upon the concrete class, rather depend upon the interface. So when we see the orthogonality, okay, when we see the orthogonality, then better be dependent upon better take the orthogonality concept through interface. So that is the sign. So now the printer has four interfaces: communication, print, fax, and step. So there are four interfaces. The client, which is using the printer class, now it has four interfaces in its hand. So either it can receive the printer class pointer, and it can take out the four interfaces that it has realized. So printer class can implement all four interfaces. And the client side, if it has printer pointed, then it can take out any of the interface that is implemented in the printer class. Now, he means idea is that client would work through interface point. Straightforward. Now, what is the concept of the orthogonal component? If I have 3D, X, Y, Z, I can kick out Z and I can make it 2D. Since XY are not dependent upon Z, so I can kick out Z. Or then I'll work in XY plane. If I kick out Y, then I'll work in XZ plane. If I kick out X, then I would work in kind of uh, YZ plane. I can kick out YZ also, then I would work along X direction. Anything I can do. That is the orthogonality. So if interfaces are orthogonal to each other, then I can kick out anything. That is the concept. Now, if I have communication module, printer print module, communication interface, print interface, staple interface, fax interface, then communication module is required to send the document. But I can kick out print and fax and staple. It will just send it in the queue. Or I can just kick out print interface itself, only communication, fax and communication and fax. So it would send and it would send the document to the printer, and then inside the printer it would fax the document. So the orthogonality, the main idea behind the orthogonality, independence in the variable, that anyone can live without any other. They are not touching it. If there is change in one direction, the change is not propagated in other direction. If you use collinear attributes, then if you make change in one direction, it will change many other attributes. That is the problem. Okay, like if you have printer class only, it doesn't follow any interface. Everything is written in printer class, all the communication and printing and stapling, and then followed by faxing. Then code are completely, they are interlocked. If you make change at one place, then you have to change many other places. That's why the ortho, you will see generally in the book that rather than doing this, then you find the different role and bring it to interface. That is not sufficient. That is not suffice, in a sense that you really professionally try to find, or through mathematically they are orthogonal to each other. So that is required. Now the client interface, it may use fax interface, it may not use fax interface. Earlier, full code was in front of the client, full printer code with all the methods. Fax, if it wants or if doesn't work, doesn't matter. So it has to use see the fax method and everything. So that is something that is not required. Now with the interface segregation, now the client component is seeing only communication module to send the document to the printer, or communication module and faxing, or communication module printing and stapling. Okay, fax is not required. This is the one big benefit that client is getting, that through the orthogonality. Okay, so independent in the sense, independence in using any interface, not using any interface. Okay, so the code at the client side is very small. If it needs small functionality, just think that a class is giving functionality of 200 interfaces and it needs only two. It will write code with two interfaces only, not 200. But earlier, if a class has implemented 200 roles, then full 200 methods are in front of the client. And that side, on the service component side, also the class has 200 for 200 different work, full methods are calling each other. So that side also, in the while realizing the interface, the client, the service component would realize all the four interfaces, what we are talking, four interfaces separate, even though it is realized. So in a non-touchable manner. That is classic. Okay. So client is happy with minimal line of code. It may not use tons of interfaces if it is not required. And in service side, it is realizing in a discrete manner. So that is great at both places. Where is the pain? Pain is to find the orthogonal interfaces. That is the pain. Otherwise, it was so nice to write all the code with if and else. So nothing pain is required. But finding orthogonal component is a big pain. I would say the biggest pain. If you are able to achieve it, then you can crack anything in the world. Okay, like I saw that in society, we find that men and women, female and male. So these are two orthogonal components. Or logically, if we are doing something else, then we can find orthogonal components in other way also. What is the age of person? How much he is earning? How many rooms he has in his house? And how many members in the family? These are orthogonal. So when we make table, make sure that the columns we are filling, all the features must be orthogonal to each other. If I say a person age, person income, and numbers of people in this family, these are not dependent upon each other. Doesn't matter that how person is aged, how much he earns. How much he earns doesn't matter how many people are in the family. Okay, poor people also have 20 members in the family, and rich people also have three members in the family. Okay, so not dependent upon it. So try to come up with a kind of a table or a class where attributes are orthogonal to each other. Use some kind of mathematical formula, deduce some kind of mathematical formula where the things would be orthogonal. So now we are talking again, we are talking about the interface segregation. So the client component now should be dependent upon the interfaces which are orthogonal to each other, and then interfaces are realized by the service component. That is the concept. Now client component, if it is a kind of using interfaces of a service component, then he may kind of out of 200 interfaces, he may need only one because they are orthogonal to each other. I am not forced to use all the interfaces. That is one thing. Second thing is interfaces can be derived. Big thing. Like if I have interface as SMS, faxing, then from faxing I can derive SMS, email, Bluetooth, many things. Now, since they are following the kind of fax interface, now client can actually can instantiate any of the SMS, Bluetooth, or email or faxing object against this point. So nice. Okay, orthogonality grows to extensibility also. If that is the concept, then open close principle, Liskov substitution, and dependency inversion also coming into the picture. So open close in the sense that if I have a fax module that is closed now. Now, if you want to interface, then you have to extend and provide the other interface or concrete layer. Like if it is faxing, then fax implementation, email implementation, Bluetooth implementation, SMS implementation, everything would come. So they follow Liskov substitution principle, means all the derived classes. So SMS would exactly overlap the interfaces of the faxing. If it is not overlapping, then you are not following the orthogonal. So orthogonal is the end. Like someone would tell, okay, how much I need to work this much, this much. Well, tell me the end. Anyone would say, okay, tell me the end. End is that if you study this much, then go for the examination. Once you pass the exam or finish the examination, that is the end. Beyond that, no need to study. So this much work. So if you are doing the kind of designing and so many things, what is the end? Come to orthogonal. That is the end. Okay, so if you come to orthogonal component, then it follows all 23 design patterns and all 5 design principles. It follows the concept of minimum space and maximum information as far as machine learning is concerned. Okay, it follows the high quality of multivariate directional derivative along any vector if calculus is conducted. It follows all the product and whatever the computation can be done in mathematical concept. Come up with the orthogonal component. That is the concept. So whatever we are talking about the interface segregation, that is very good when it is a kind of the interface when in design pattern we use the strategy design. So if a strategy design pattern, if I have a method, then inside the method we can use these pointers and we can follow the orthogonality in the interface. So what good thing we are getting is that interface Okay, so interface programming, when we go there also, we have introduced the independent variable, independent component. So that is the concept that we are following. Okay, so it is hot, but good thing is that sometimes it is cloudy. I mean, it is not overcast, but there is a shade. Sometimes it is sunny. So in between. So we'll have something to break the heat. Let's see. Okay, it may not be kind of watery stuff. Let's see. Okay, so this is called butterfruit fruit and it is cultivated. It is a tree and it is cultivated at high altitude, like in India, Karnataka area, or in kind of Sikkim area, where the altitude is very high, kind of 1,000 meter and those kind of. So let's see. Okay, so it is rich in kind of vitamin E, and it is almost rich in vitamin E, and it has almost means these two are the thing, or it is full fat. So it is called butter fruit also. Means it is full butter. Okay, if you see, it is full butter. Really, really, it is. It is not sweet, means, but it is kind of different. It is full butter. So it is also called, and it has big seed inside it. Means it is really very nice. It is full butter. Okay, then enjoy orthogonal components, and I'll enjoy the butter fruit.